Welcome to this brief demo of carrier-grade network address translation, known as CGNAT, being supported on the RtBrick BNG. ISPs globally require a mechanism to address the problem of depleting public IPv4 addresses. This mechanism is CGNAT. In brief, thanks to the Network Address Translation Service, a single public IPv4 address is shared by a number of subscribers and provisioned by the NAT service. Apart from solving the public IPv4 address depletion problem, NAT also keeps the internal addressing private from the external network. Let's go over the demo topology. On the right, we can see our x86 server is hosting Service Node and Grafana. Service Node runs multiple VNFs, including BNG Blaster and Radius Server. BNG Blaster is an open-source tool which helps in simulating the PPPoE and the IPoE subscribers. It also helps in simulating the internet connectivity. While for the Radius server, free Radius is used for AAA services. Grafana connects to the Prometheus database running in the BNG for telemetry visualizations. On the left, we can see the device under test, or DUT, which is a BNG and CGNAT device powered with RBFS software, running on the Broadcom Qumran 2C chipset. The DUT is connected to the service node using two ports. The access port is facing towards the subscribers, or the internal network, while the network port is facing towards the internet, or the public network. With the help of the BNG Blaster tool, 24,000 subscribers, with more than 4.5 million traffic flows, are established on this device. Along with this, IPv4 and IPv6 internet feeds are also downloaded. Now, let's go to the demo environment. This is our DUT. Let's look at the relevant configurations which enable the CGNAT service for the IPoE and the PPPoE subscribers. At the top, an IPv4 public address pool is configured. A public address from this pool is shared by multiple subscribers to connect to the public network. Port block size is configured, which helps in pre-allocating a layer 4 port block to the subscribers. This facilitates achieving the deterministic CGNAT service. And another pool is chained to the existing pool, which helps in a flexible and scalable net pool management. This pool is used by the NAT service profile below. In the profile, TCP and UDP protocols are supported for the CGNAT service. Max rule is configured to limit the number of traffic flows for a subscriber. Let's look at the access configuration, which uses NAT profile to enable the CGNAT service. Here, the access port is configured to provide the internet access to the IPoE and the PPPoE subscribers. A service profile is used to enable the access services. Along with the quality of service profile, NAT service profile is also configured to enable the CGNAT service. The BNG is also configured to collect the various telemetry stats, which are plotted on the Grafana dashboard. We'll take a look at the Grafana dashboard at the end of the demo. Since we have seen the configurations at the DUT, let's now go to the BNG Blaster tool. Here, 24,000 subscribers are established with more than 4.5 million traffic flows. The BNG Blaster also helps the DUT to learn the internet feeds. Let's see that in the BNG. We can see that the 24,000 subscribers are established here. The IPv4 and IPv6 internet feeds are also downloaded. We can see that more than 4.5 million address translation roles have been programmed. Let's now pick a traffic flow and verify the address and layer 4 translations using the BNG Blaster command. BNG Blaster keeps track of the original and translated IP address and layer 4 ports. This is the traffic flow from subscriber to the internet. The original source IP is a private IP, and the source port is 65190. At the bottom, we can see the translated source IP is a public IP address allocated to the subscriber from a NAT pool. Translated port 1309 is from a port range assigned to the subscriber. Let's see this in the BNG. This command shows the translated IP address and port range allocated to the subscriber. Let's match this with the traffic flow in the BNG blaster. The address matches. Let us see the source port. The source port 1309 is allocated from the port range assigned to the subscriber. Let's briefly verify the traffic flow using the TCP dump command. We can see here at the network port the packets are received with a translated IP address, while at the access interface, or access port, the destination IP address is the subscriber's IP address or private IP address. With this, we've verified the NAT in-play for the traffic flows. Let's take a quick look at the Grafana dashboard for telemetry visualizations. We have collected subscriber stats, NAT tool stats, and routing stats from the BNG. We can see that 24,000 subscribers are established. More than 4.5 million NAT rules are programmed. At the same time, IPv4 and IPv6 internet feeds are also downloaded in the device. Let's summarize with the key CGNAT functions supported on the RtBrick BNG. CGNAT is supported for the TCP and UDP flows for IPoE and PPPoE subscribers. Deterministic NAT is in place. A flexible NAT pool management is supported using next pool configuration. NAT flow aging helps to keep track of the live flows. And with that, we conclude our demo. I hope that was useful. Thanks for your time and attention. If you have any further questions, why don't you get in touch with us or visit us at rtbrick.com.